Hi everyone, welcome to my channel Rajguru Chemistry. Today in this video, we are going to discuss the topic of electrochemistry. In conductometric titration, acid-base titration, we can take the example of mixture of acid versus sodium hydroxide. Mixture of acid contains a strong acid as hydrochloric acid and weak acid as acetic acid. What is conductometric titration and what are the principles of conductometric titration are given in the previous video. The link is given in the description box. In the previous video, we have discussed the topic of strong acid versus strong base and weak acid versus strong base. Now let us come to the topic of mixture of acid and sodium hydroxide. Now let us come to the practical session for mixture of acid versus strong base. The aim of this experiment is to determine the strength of strong acid and weak acid in a given mixture by conductometric titration. The requirements are hydrochloric acid, sodium hydroxide, acetic acid, burette and 20 ml pipette, beaker, glass rod and conductivity meter with cell. The given solution is made up to the 100 ml SMF up to the mark using the distilled water. 20 ml of this mixture of solution is pipetted out into a clean beaker, then added 30 ml of water so that conductivity cell is completely immersed in the solution. The conductivity cell consists of two platinum electrodes in which one of the electrode is act as an anode and another act as a cathode. Now we will see the titration starts. What happens? That is, before the titration only mixture of acid present. This mixture contains hydrochloric acid and acetic acid. Hydrochloric acid is a strong acid and acetic acid is a weak acid. The titrant is a sodium hydroxide which is taken in the burette. A standardized solution of strength of 0.5 N sodium hydroxide solution is taken in the burette, added 0.5 ml portions. The solution is stirred well and allowed to attain the equilibrium. Then see the conductivity of the solution between two electrodes because of the movement of the positively and negatively ions of the opposite electrodes. It shows the conductance. Before starting the titration, only mixture of acid present. This mixture contains hydrochloric acid and acetic acid. Hydrochloric acid is a strong acid. It will be completely dissociated into ions, and acetic acid is a weak acid. It does not dissociate immediately. Hydrochloric acid will be dissociated into ions and presence of H plus ions with high ionic conductivity, high ionic mobility and high conductance. An alkali is added, the H plus ions removed as feebly ionized water molecules. The conductivity of the solutions decreases due to the replacement of H plus ions by slow moving Na plus ions till the neutralization point. Till the equivalence point or neutralization point of HCl, because we have two acids but we are taking only neutralization point of HCl acid. Now sodium hydroxide is added to the mixer. HCl reacted with the base. It gives Na plus and Cl minus. Since the conductance will be decreases slowly, slow moving Na plus ions are replaced by fast moving H plus ions. So the conductance decreases till the equivalence point. HCl is completely neutralized. And adding sodium hydroxide, acetic acid reacts with the sodium hydroxide. It is a weak acid, it does not dissociate into ions and it cannot be represented as ions. All acetic acid is neutralizes to form sodium acetate. At the neutralization point, HCl and acetic acid are not present, and accumulation of OH minus ion with high ionic mobility as the conductance increases drastically. Finally, we draw the graph, plot all the points and draw these three lines. We see that the maximum number of points following the lines, we get two intersection lines. The first point is sodium hydroxide required for the complete neutralization of hydrochloric acid. The second point is the volume of sodium hydroxide required for the complete neutralization of acetic acid. From the graph value, we can calculate the strength of strong acid and strength of weak acid. We know that the strength of sodium hydroxide is 0.5 N. Volume of sodium hydroxide is arrived from the graph. Volume of hydrochloric acid is 20 ml. From this value, we can calculate the strength of hydrochloric acid present in the mixer. The second step, we have to determine the weak acid strength. Strength of sodium hydroxide is 0.5 N. Volume of sodium hydroxide is given from the graph. Volume of weak acid is 20 ml. From this value, we can calculate the strength of weak acid present in the mixer. As a result, the strength of strong acid present in the given mixer and the strength of weak acid present in the given mixer can be calculated. In normal titration, we cannot find out the two acids. It gives a single value, single titer value only. But this is the major advantages in conductometric titration. I hope you like this video. Share the video with your friends. Do subscribe the channel and click the bell icon to get notification. Thank you.